Good afternoon, everyone, and welcome to our Renewable Liquid Gas Showcase webinar. My name is Eva Abramik-Lete, and I'm General Manager of Liquid Gas Europe. We are thrilled to have you with us today as we explore the innovative solutions and potential of renewable liquid gases in the energy transition. A quick note before we begin. We'll start with the presentations, followed by a Q&A session. Feel free to submit your questions at any time using the Q&A function. So let's dive in. Today, we'll take you through an engaging session about Liquid Gas Europe's Renewable Showcase initiative. We are thrilled to have a distinguished panel of speakers here to guide us through this exciting journey of progress, purpose, and planning. Today's agenda will cover 4 key points. First is what is the LG Renewable Showcase? Secondly, what is the purpose of the showcase? Thirdly, what have we done so far and what we hope to achieve? And finally, planned next steps. We are proud to introduce a dynamic panel of experts who bring a wealth of experience and knowledge to today's discussion. Along myself, we'll have Wendy Binst, representing FebuPro, the Belgian Propane and Butane Association, Julia Coelho, a technical officer at Liquid Gas Europe, and John Taylor, Liquid Gas Europe Sustainability Manager and the project lead. This session aims to provide not just an update, but a compelling case for why renewable liquid gas is an integral part of our shared energy future. Through collaboration, innovation, and clear next steps, we aim to make impactful contributions to achieving sustainable, resilient, and inclusive energy system. We look forward to an insightful session and encourage you to actively participate in the discussion and Q&A. Let's work together to drive progress in the renewable energy sector. Before we start about the project, let me very quickly introduce what Liquid Gas Europe is. Liquid Gas Europe is a Brussels-based association and the voice of European liquid gas industry, advocating for a safe and stable regulatory environment to support a just energy transition. Our vision is to enable the industry transformation towards renewable liquid gases, ensuring energy security and inclusivity for all, on the road, in homes, and off-grid. But let me now explain a little bit about the project. So on our next slide, you will see 2 questions, why and who. Why? So why did we do this? Well, the goal is to showcase the transition from traditional LPG to bioLPG, demonstrating how it can achieve rapid defossilization. By integrating energy efficiency measures and indoor environmental quality monitoring, this project aligns with the principle of the Energy Efficiency Directive, emphasizing energy efficiency first approach. Indoor environmental quality monitoring, now required by the revised Energy Performance of Buildings Directive, underscores the importance of healthier living spaces alongside sustainability goals. Ultimately, these initiatives aim to position the liquid gas industry as a pivotal partner in Europe's energy transition. This is a collaborative effort led by Liquid Gas Europe, partnering with industry leaders such as UGI International, SHV Energy, DCC, and Cavania Group. It also includes collaboration with FebuPro, Belgian Propane and Butane Association, ensuring diverse expertise and shared commitment to promoting renewable energy solutions. With that, I would like to hand the microphone to John, who is going to explain the details of today's project.
Okay, thank you very much, Eva, for setting the scene for the showcase project. And my job now is to give you some more details about the project. First of all, where is the showcase site located? Well, it's located in Belgium, in a village called Klein Vlaslaar, near a town called Rotselaar, and it's about 30 kilometers from the center of Brussels. What about the actual building at this site then? Well, it's a building that has 2 parts, and it has 2 heating systems, 1 heating system in each part of the building. The new part of the building was built in, when it was built, it was equipped in 2016 with LPG. So right from the start, the new building in 2016 had a supply of LPG to provide the heating needs of the building. The older building, or the old part of this building, originally used heating oil for its heating needs, but it was also converted to LPG in 2018. So both parts, the old and the new part of the building, were both switched to 100% biopropane in 2023. So I'm going to use the term biopropane throughout, but what we also mean by biopropane is bioLPG. We also installed meters, gas and electricity meters, in May and September 2024. On my next slide, you will see some photographs, which gives you more details about the building. On the left-hand side, you can see a plan view of the site. The company that operates this building is called ADEM. This is a non-residential building, and it's located in a rural area that provides, and the purpose of the building, the purpose of the organization is to provide assistance to people who have special needs, people of all ages. It's located, as I've already mentioned, in a small village, and it has a large garden. And in that garden, there is actually a small farm with farm animals like goats and sheep and pigs, in fact. And it has a vegetable and fruit garden. And the garden is used by the residents of the care home. As mentioned previously, although it looks like one building, it's actually two buildings, an old building and a new building. And on that photograph on the left-hand side, you can see the two parts of the building marked out. And each part has its own heating system. So to tell you a bit more about the heating system, I have another slide. The two photographs on the left-hand side show you the two bulk tanks that supply the liquid gas, which is used for space heating and domestic hot water. One building has an underground tank. That's the new building. The photograph on the left-hand side, that's the underground tank. And the old building, has an above-ground tank, which you can see on the right-hand side of the photographs on the left. On the right-hand side, you can see the two boilers, the two heating system boilers that are used in each building. Now, these boilers operate from 6 in the morning until 10 o'clock at night, 7 days a week. The boilers make use of something called weather compensation, where the boilers adjust the flow temperature, the flow of hot water from the boilers, according to the outside air temperature. So if it's colder outside, the boiler flow temperature is increased. If it's warmer outside, the boiler flow temperature is reduced. And this helps optimize energy consumption. Both boilers seek to keep the indoor air temperature at 24 degrees Celsius for the comfort of the occupants. The old building heats the internal spaces using traditional radiators, whilst the new building has underfloor heating elements to heat the rooms. So those are the heating systems. Now let me talk a little bit about the biopropane. ADEM, the company that operates the buildings and that provides the services to the residents, was switched from LPG to biopropane, otherwise known as bioLPG, in 2023. Biopropane is a renewable fuel derived from sustainable sources such as plant and animal waste. It offers a cleaner, greener alternative to conventional LPG, with the potential to reach net zero by 2050. This biopropane is produced in a biorefinery, which you can see indicated on the illustration below. And that biorefinery uses HVO or HEFA pathways to produce a biofuel. The biopropane is the byproduct of the production of another target biofuel. As you can see on this illustration, the target fuel is identified as sustainable aviation fuel. It could, however, be renewable diesel, but that's the main biofuel that's produced by the biorefinery. The biopropane is a byproduct. All of the biofuel, the sustainable aviation fuel or the biopropane, is produced from an organic feedstock. In this case, for the most recent supplies of biopropane to the showcase site, the feedstock has been rapeseed oil. The plant or the biorefinery that produced this biopropane has been producing biorefineries since 2018. The biopropane is mixed with conventional LPG, but using a mass balance approach. The distributor ensures that only the precise amount of biopropane that enters the supply chain can be sold as biopropane to the end user. The biopropane supplied to the showcase site is currently certified using the ISCC Plus scheme. ISCC Plus is a voluntary certification scheme for non-regulated markets, as opposed to ISCC EU, which is recognized by the European Commission to demonstrate compliance with the sustainability and greenhouse gas emission saving criteria of the Renewable Energy Directive. The distributor of biopropane to the Aden site, however, is in the process of moving to ISSC EU scheme, and it is planned for this to be in place early in the new year, which is very good news. I'm now going to hand over to my colleague, Julia, who's going to talk to you more about what else we've done at the showcase site, in addition to switching them from LPG to biopropane. Over to you, Julia.
Thank you very much, John. So in this showcase, we haven't just switched the fuel of the building. So we are also focused on improving the energy efficiency and also indoor environmental quality for the customer. So besides the ISCC Plus certification, we also asked IMOPAS to conduct an energy performance certificate and an energy audit, which was conducted by an architect. So we could identify a benchmark and also where the building needed some improvements in terms of energy efficiency. When we started the project, the customer could only estimate their gas consumption based on tank volumes. So we also installed smart gas meters from Soper, Cavania Group. And now with this telemetry data, they can monitor the usage in real time and gain a comprehensive view of the energy consumption patterns, enabling them to optimize usage, reduce energy, and make more informed decisions to enhance efficiency. The latest installation we've conducted was electricity submeters, one for each building, so we could see how each building is consuming their electricity, and also 7 indoors environmental quality sensors in strategic rooms, so we could monitor the indoor environmental quality for the customer. For the energy performance certificate, so the EPC, we received an X rating, which varies from A to G, since we didn't have the latest year of gas consumption readings. The energy score we also received was equal to 1,179 kilowatt-hour square meters per year, which is the expected energy consumption of the building calculated according to the building structure. So insulation of walls, roofs, windows, etc. And this is a base number that can be used to compare with the real energy score that we are going to receive after 1 year of readings. Some structural weaknesses were identified with this EPC, and we now know that doors and gates were the most critical structures. We are also informed that even if we had all the readings needed to have a rating different from X, it will be not higher from a G, because the building needs to be to consume at least 10% of renewable energy produced. And for the EPC calculation, this building is not consuming any renewable energy. So our question at that time was, what about our biopropane? So we have today with us Wendy Binst, is a representative of FebuPro, and she's going to explain this problem further to you. Over to you, Wendy.
Thank you, Julia. And also a sincere thank you to the care facility Adem, a care facility where the green vibe is consistently reflected in their philosophy and therefore also when it comes to energy. Biopropane is a powerful step towards a more sustainable world, and that together with a very smooth transition, well, we can say that the LGE showcase demonstrates that renewable energy is within reach for everyone. During this fascinating showcase, several actions were taken at the customer premises, including an assessment of the energy performance. For this, we received an EPC certificate by an assessor, as explained by Julia. But upon receipt of the report of the certificate, it became clear that the score did not further improve with the use of 100% biopropane as an energy source for the building of Adem. After further investigation and discussions with the assessor, it became clear to us that renewable energies that are not produced on site at the customer's premises, just as biopropane, are not categorized as a valuable renewable energy at all, but unfortunately as a fossil fuel. The inspection protocol for the energy performance certificate for non-residential buildings, in this case, states that liquid biofuel is not considered renewable. Because biopropane is not recognized and therefore not included in the formulation of the EPC, so at no point biopropane is recognized neither in the indicator list nor in the technology list of the inspection protocol. Biopropane is in line with the RED directives and complies with the ISCC guidelines. Despite this, we are categorized with biopropane in the category propane, under the definition another fuel by equalization as a gaseous fossil fuel and gaseous fuels extracted from biomass outside the own site. In short, it means that biopropane is given the fossil propane label. This means that people who use biopropane as their primary source for the building cannot get a score higher than G in the energy performance certificate because there is no on-site production. FebuPro is now requesting and starting up discussions with VEGA, the Flemish Climate and Environmental Agency, to address this matter. This is important information that we have uncovered thanks to this LGE showcase with Adem. This gives us the opportunity to work on the inclusion of biopropane and to achieve this through the various processes, whether it's EPC, whether it's administration or taxation. The renewable liquid gas, biopropane, deserves a place in an inclusive energy matrix for the future. It's a renewable energy source that offers the same benefits as fossil fuels, but with very low CO2 emissions. It gives us the opportunity to directly contribute to reducing our ecological footprint without compromising on performance or comfort. So choose biopropane and take with us the next step towards a greener future. And with great enthusiasm, I give back the floor to John.
Thank you, Wendy, and thank you for explaining how biopropane is a very key, or could be a very key part of the energy transition in rural areas to achieve rapid decarbonisation. Now, my task now is to explain to you the other parts of the project, which Julia has also already referred to. And the question you might be asking is, why have we incorporated energy and indoor air quality monitoring into the Showcase project? Well, it's simple, really. Citizens and businesses are concerned about using the energy they procure as efficiently as possible, so little or none is wasted. And they're also concerned about the quality of their indoor environment. A balance, of course, needs to be struck between energy efficiency and comfort. And of course, the EU Commission has targets for improvements in energy efficiency as part of its net zero strategy. The Energy Performance of Buildings Directive talks about the creation of a digital building twin, and that's what we have developed with the energy and indoor air quality monitoring systems we've implemented at the showcase site. The Energy Efficiency First principle, which is a key element of the Energy Efficiency Directive, specifically recommends that continuous monitoring, analysis, and reporting of energy efficiency in buildings is required. Through this showcase project, we are demonstrating the value of our industry as a partner for the energy transition in rural areas. We can help achieve rapid defossilization of buildings by supplying biopropane, given the right assistance. We know how to help users avoid energy waste, thus further reducing greenhouse gas emissions. And we also know how to monitor and improve environmental quality. On the next slide, we have some illustrations of the digital twin that we've implemented or we're implementing at the showcase building. These two charts show the daily consumption of gas, one chart for each building. The chart on the left is for the new building, the chart on the right is for the old building, with the height of the blue bars indicating the amount of gas consumed in cubic meters per day, 1 bar per day. The red line, or the orange line as it's showing up on these charts, indicates something called heating degree days, which is a measure of the outside temperature for each day. The more heating degree days in a day, the colder it was. The fewer, the warmer it was. The more heating degree days, the colder it was, you would expect greater gas consumption. And when it's warmer with fewer heating degree days, you'd expect less gas consumption. And this is largely, although not completely, what we see. Each day, whatever the weather, there is what is called baseload consumption. So even if it was perfect temperature, 24 degrees Celsius inside the building and perhaps higher outside, there would still be gas consumption because gas is consumed, if you remember from what we said earlier, is used for domestic hot water demand, for washing and for cooking. So it's used throughout the year. Sometimes we see changes in weather which do not appear to be in line with gas consumption, and that's sometimes. This is something that can occur when changes are made to the heating control systems. We will be investigating this further. Generally, though, the systems appear to be performing satisfactorily. 2 more charts for you. These 2 charts are for the same heating systems, and they're widely used in energy efficiency management systems. They show the relationship expressed as an equation derived from the plot between gas consumption and again heating degree days. What we are looking for a system that is performing efficiently is close correlation between gas consumption and heating degree days. The closer the dots are to the straight line, the closer the correlation. Ideally, we want a correlation coefficient, which is, as you can see in the equation in the bottom right-hand corner, R2, we want that to be as close to 1 as possible. That would mean perfect correlation. Again, we will look at this more closely with the building's heating technician as the project progresses. What we are providing here with this analysis, these charts and this digital twin, is a valuable service for the building occupier to help monitor and improve energy efficiency. These equations that have been generated can be used to predict future energy consumption, which can be compared with actual energy consumption to determine whether any changes made were effective. For example, have savings actually been made by the changes that were made. This method, known as regression analysis, is actually a rudimentary form of AI. So our digital twin is making use of AI. On the next chart, you can see further details about the digital twin that we've implemented at the Showcase building. More recently, in September, we have also added electricity consumption and indoor environmental quality sensors to our digital twin. Our initial focus with respect to electricity consumption will be on baseload consumption. That's the consumption when everyone, for example, is in bed. And the question then is, why are we still consuming electricity? And also variations in day-to-day consumption. For example, why was 12% more electricity consumed on the 25th of November than on the 24th of November? We'll also be looking at data from the indoor environmental sensors. For example, why is one room at 18 degrees Celsius when another is at 23 degrees Celsius at the same time? I'd now like to hand back over to Eva to talk about the policy asks we'd like to make on the back of this Showcase project.
Thank you, John. Thank you for your introduction to the project. As we transition towards sustainable energy future, bioLPG offers us an important solution for decarbonization, particularly in hard-to-electrify sectors and off-grid areas. And today I would like to highlight 3 critical policy actions needed to unlock its full potential. First, incentivize bioLPG as a solution for energy transition in rural and off-grid areas. These communities face unique challenges, such as limited infrastructure and high electrification costs. Targeted measures like tax breaks, grants, or subsidies can accelerate the adoption of biopropane, providing an immediate and scalable low-carbon solution. These incentives ensure a fair and inclusive energy transition, supporting communities that are often at risk of being left behind. Secondly, adopt strong policies to scale up biopropane production. Demand for renewable energy solutions is growing, and bioLPG versatility makes it essential to decarbonize hard-to-electrify sectors. Scaling up production requires investments, innovation grants, and long-term policy signals to attract private funding. This will drive efficiency, reduce costs through economics of scale, and secure bioLPG role as a widely available, cost-effective renewable energy source. Finally, recognize biopropane in building decarbonization policies. Biopropane is a practical low-carbon option for heating and cooking, especially in existing buildings where retrofitting for electrification is costly or unfeasible. Moving forward, heating policies must explicitly include biopropane beyond 2035, as it will remain crucial for decarbonizing heating in rural and off-grid areas. By addressing these policy gaps, we can ensure that biopropane, bioLPG, plays a vital role in Europe's energy transition, reducing emissions and supporting diverse energy needs. Thank you very much, and I would like to hand the microphone to John to discuss lessons learned and next steps with regards to the project.
Okay, thank you very much, Eva. So what have we learned so far from the Showcase project? Well, the first thing that we learned was that for the EPC assessor to give us a rating beyond X, that what we needed was 12-month, the immediate previous 12-month meter readings from gas and electricity meters. Now, we had electricity meters already in place, or a main meter, but it wasn't until we started the project that we installed gas meters. So we won't have that data until 12 months after the first EPC, which is going to be around about June 2025, when we'll have an EPC rating other than X, which will be very interesting for us, and we'll be able to see how much we've been able to improve from that 1179 kilowatt hours per square meter per year that Julia identified previously as the calculated expected consumption of the building. We also learnt, as Wendy has described, that biopropane is not recognized as renewable energy in Flanders, for the purpose of a higher EPC rating, and we're obviously investigating that with the appropriate authority in Flanders. We've also learnt that the boiler control systems are utilize simple time control with the temperature set points. They don't utilize optimization, which is would be an improvement in the control system, which would cause the boilers to turn on at rather than a fixed time every day and turn off at a fixed time, to turn on and off at the optimum time according to the outdoor temperature and the indoor temperature. So that would be an improvement over the controls, the way the boilers are actually controlled. We've also seen some possible evidence of heat and control system issues in the occasional poor correlation between gas consumption and external temperature, although we do need to investigate that further with the heating technician that looks after the heating systems at the building. The EPC assessor identified the need for better insulation, but also flagged the boiler as not meeting long-term goals. So that's also something that we would like to discuss with the Flemish Energy and Climate Authority, because if the boiler is consuming renewable energy, renewable liquid gas or biopropane, then why can't it meet long-term goals for net zero? Solar energy is mandatory for existing non-residential buildings bigger than 500 square meter floor area by December 2027 in Flanders. So that's something that the building occupiers need to consider, and we can also discuss that with them as well. And both the EPC assessor and the energy auditor both stated that the building would benefit from the installation of solar photovoltaic panels to generate on-site electricity. So what next? And on my next slide, I will be describing what next. Thank you. So the first thing to say, an important thing to say, is that this showcase project is not a one-time project. It will be an ongoing story of sustainable development. One of the biggest mistakes made by building designers and operators is to assume that once a building has been improved, it will stay improved. But it will not, unless it's monitored and maintained day by day, week by week, because changes are inevitable. And these changes will impact the building's energy and comfort performance. People change. People change how systems operate. Equipment is maintained and adjusted. The use of buildings change over time. All these changes could have a detrimental effect on the building's performance. So the building needs to be continuously monitored to ensure that it always operates at its sweet spot. So we will continue to do this, and we will look for and implement improvements with the building operator as appropriate. So that's one of the most important next steps we will proceed with on this showcase project. In spring, sometime in spring, either early or late spring, we're in the process actually of organizing an on-site visit to which we will invite policymakers. Local policymakers, regional policymakers, national policymakers, and EU policymakers, to show them this showcase site, to show them what we're doing, what we've installed, and what the benefits are of the use of biopropane and the use of energy efficiency and indoor environmental quality monitoring. The distributor of biopropane to the site is also in the process, as I mentioned earlier, of making use of ISCC EU certification, which is great news for this showcase project. We will also be advocating for biopropane recognition in all relevant regulations and directives. So those are the important next steps in this project. And I'm now going to hand over to my colleague again, Julia, who's going to moderate any questions. Thank you, Julia.
Thank you very much, John. Thank you, Eva. Thank you, Wendy, for the presentation. So as John said, we will now move to the Q&A part of the webinar. I would like to have this opportunity to welcome Matti from FEBUPRO. He's the FEBUPRO Secretariat, who will also support us on this Q&A. So if you haven't done so, please share your questions with us and we'll be happy to clarify them. I can see that we already have some questions here in the Q&A. So I'll just read it. Given that biopropane is not currently recognized as a renewable energy source for EPC ratings in Flanders, what steps can be taken at both regional and EU levels to change this perception and policy? I'll give this question to Matti.
Okay. Thank you, Julia. So, of course, this is indeed an important challenge, and we're also grateful to this showcase that it has brought it to our attention. Of course, what is important to understand is that the EPC, it's a score for a building. So it's a score not per se for a fuel, it's a score for a building. And that's why, in principle, the focus is on on-site generation, because heating technologies with a direct impact, it's very easy to kind of prove the sustainable character of these technologies, like a heat pump, like a solar panel, etc. The challenge here is that the renewable character of biopropane it's an externally sourced renewable energy, and of course it is certified via ESCC plus, but policymakers are reliant on the certification by the suppliers in order to make sure that it's indeed renewable. And there, the challenge, of course, is that EPC and creating these documents, it's a snapshot. So even if they were open to recognizing a bioLPG, how can you guarantee that this building, this user, will continue to keep using bioLPG in the future? So I think we have to recognize also the challenges from the side of the policymaker, and as an industry also come up with solutions on working together, making sure on providing this with guarantees of the sustainable character of the supply chain of bioLPG, in order to make sure that indeed bioLPG can have a place in the energy mix of the future and can also contribute to better EPC scores.
Okay, thank you very much, Matti. I think it was very clarifying. I'll move to the second question. So what kind of policy incentives for biopropane will LG ask for? Eva, I'll hand this to you.
Thank you. Thank you for the question. I think it's a very valid question. We are going to look very in-depthly into answering that in the next couple of weeks. Why? It's because we are publishing a new study. It's an outlook for renewable pathway production, let's say pathways for production of renewable energy, and also possible availability of renewable biopropane in Europe in the future, 2030, 2040, 2050. And with that, of course, we identify a number of asks, and so more of those asks will be shared with you very shortly. However, of course, I think what we learned from this project is this recognition in policy frameworks is very important. And it's not only in EPCs, because it really depends on the country. And in this case, in Flanders, it's not recognized, but in other countries it is. So I think this consistent recognition of biopropane in policy frameworks is very important. Alignment with the Renewable Energy Directive, which we already have in place, but there are more details that needs to be clarified in there. For other incentives, we of course are looking into subsidies for transitioning from fossil LPG to biopropane, issues like tax credits, reduced VAT, grants for pilot projects, but also into targeted programs for rural areas where electrification is more difficult. So there's a number of issues we are looking into. I can spend a long time describing that. We will have a dedicated session to that very soon with the launch of the study planned in March. So I also would like to, at the same time, to invite you to join that. So with that, I think in general, there's several issues that needs to be done for biopropane to succeed in the future and to scale up the production, but also to ensure that we have customers that can be supplied with this product without any big interruption.
Okay, thank you very much, Eva. Moving to the next question, has combining this solution with a heat pump has been considered as an option to reduce the consumption of low carbon fuels? I believe, John, I can give this to you.
Yes, we haven't actually included that in the project at this time, but that's not something that we would necessarily avoid in the future. That is something that possibly on another showcase site we would be very interested in utilizing multiple technologies: heat pump, CHP, etc., solar, thermal, solar photovoltaic. So perhaps, if there's anybody in the audience thinking we would like to develop a similar showcase in our member state or in our country, it doesn't have to be in the EU, then we could look into that as well, because hybrid heating systems are obviously well recognized, and that's something that we would be interested in investigating as well.
Okay, thank you very much, John. What policies would support scaling up biopropane production? Eva, could you please?
Well, thank you. I think it's to support the scaling up of biopropane production, we need a combination of regulatory, financial, and market-driven policies. And these policies should focus on creating a favorable environment for investments, innovation, and key market developments. And at the same time, it does need to ensure that demand grow, because without that, obviously, these investments will not happen. These can include financial incentives for productions, research and development support, or better or streamlined regulatory frameworks. And then obviously the market developments, so collaboration between public and private companies. Obviously, we need to look into things like carbon pricing and tax differentiations and international collaborations, as we see that more and more that happens in the liquid gas industry.
Okay, thank you very much, Eva. We have a question now from Emmanuel Manot-Retonil. What are the other feedstocks that can be used to produce biopropane, and what is the range of GHG savings achievable? I don't know if John or Eva who would like to answer to that.
Would you like me to go ahead?
Yeah, go ahead, John.
Yeah, okay. I've been caught on the hop here because I always struggle to remember the different feedstocks. But any organic lipids, I think, would come under the description of sustainable feedstocks for biopropane production. Biogas, there are early developments in the conversion of biogas to renewable liquid gas, and also to another renewable liquid gas, renewable dimethyl ether, which can be combined with biopropane or bioLPG, so biogas, lipids, and also I was also going to mention carbon dioxide and hydrogen can be combined to produce what's called eLPG, which is an alternative form of renewable liquid gas. So there are many different feedstocks that can be used using different pathways to produce renewable liquid gas. And as Ava's already mentioned in our Pathways report, which will be published very shortly, you'll be able to get the full details of all the feedstocks that we've considered, we've analyzed, we've evaluated the availability of those feedstocks for the production of renewable liquid gas that can be used in residential, non-residential, industry, and commercial buildings, which could have their own showcase projects. But I hope that's answered your question satisfactorily, Emmanuel. Perhaps you'd like to suggest some more feedstocks if I've missed some that you would like to bring to my attention.
Okay, thank you very much, John. So moving to the next question, with the lessons learned from the Leuven Care Facility project, what would be the top policy recommendations to encourage broader adoption of biopropane and similar renewable gases in buildings across Europe? Eva, I will hand this over to you.
Thank you. It's not the easiest of the questions to answer. Let me try to have a grasp on that. Well, definitely we see with the EPC issues that we need to look into the incorporation of renewable gases into EPC frameworks. We definitely, top priorities is provide financial incentives and highlight off-grid solutions, and then I think support awareness campaigns. I am still faced with the fact that many do not know what bioLPG, renewable or LPG or biopropane is, and hence it's then more difficult to integrate that into national priorities and national legislation. So on top of what I've already said, perhaps just to highlight those couple of points. Thank you.
Okay, thank you very much. And the next question is from Goher Mir. So how critical is EPC scores towards showing compliance with EPBG requirements at national level? And do you see any disconnect between two frameworks with regards to bioLPG recognition? Maybe John would like to take this one.
Yes, I can do. So I think the question is, you might need to repeat that. Just repeat that again if you wouldn't mind, Julia.
Yeah, of course. So how critical is EPC scores towards showing compliance with EPBG requirements at the national level? This is the first question. And then do you see any disconnect between two frameworks with regard to bioLPG recognition?
Yes, I do see a disconnect, or rather, we've seen what appears to be a disconnect in the EPC guidance that the EPC assessors in Flanders use compared to the Energy Performance of Buildings Directive. But that disconnect might be to do with a timing issue. We know that in the current Energy Performance of Buildings Directive, the one that's just been adopted earlier this year, or was it last year, but very, very recently. And we've been involved in stakeholder meetings with the Commission on this, and we've been assured that biopropane, bioLPG, biofuels would be classed as a carbon-free energy source for use in buildings, and would contribute to the achievement of what's termed a zero-emission building. So we have those assurances in the new Energy Performance of Buildings Directive. There is a clear recognition amongst the policymakers that boilers are separate from the fuel that's combusted in those devices. So which is, something that we've challenged, this concept of a fossil fuel boiler. Well, it's not a fossil fuel boiler unless it's combusting fossil fuel. And we know that a boiler designed to combust fossil fuel can also combust renewable liquid gas. So it's then a renewable liquid gas boiler, not a fossil fuel boiler. So I think it is important that the EPC an EPC rating should not be constrained by the type of technology that the building uses. I think that's unfair, and that runs counter to the mantra of technology neutrality that we often hear from the Commission. So I think it's important that both at a national, regional level, that the EPC recognizes and allows for the use of truly renewable fuels as renewable energy. Yes, I know it's not the same as generating electricity on site, which seems to be crop up regularly. But if it's still a source of renewable energy, then it should be recognized and utilized in the EPC rating. So that's something that we need to advocate and challenge strongly. I think we're on the right course with the EPBD. We just need to make sure that the regulations are in sync. Hope that answers your question.
Thank you very much, John. Another question I think is for you. So how do you see this pilot project scaling up? And what factors should be considered to replicate this model in other regions with similar infrastructure and energy needs?
So yes, I would really like to see this project scaled up. I'd like to see it scaled up first in other countries, in other member states, in rural areas, obviously, because that's where our primary focus is. And I would like to see it scaled up by implementing similar solutions, driven by the use of renewable liquid gas in different types of buildings and different types of organizations, not just in this case, non-residential, but what about residential? What about, commercial? What about a hotel or a restaurant? What about a school? What about industrial use of renewable liquid gas? So it'd be great to see a variety of showcases so that we can illustrate to policymakers that this is a renewable energy source that can be used widely, because those types of buildings are widely found in rural areas throughout the EU and throughout Europe. So I'd like to see it scaled up in those two ways. More countries, different types of energy users. And what was the other part of your question, Julia? You had a second part, I think.
It was what factors should be considered to replicate this model in other regions with similar infrastructure and energy needs?
Okay, so the factors, obviously, an important factor is there a readily available source of renewable liquid gas to supply economically to the showcase site. And I would say that what we've learnt from this showcase project, we can implement the solutions, the energy monitoring, and the indoor environmental monitoring systems, more economically with scale. You take one site, it's more costly than if you do 2 or 3 or 4 or 10. We've learnt aspects about the implementation and working closely with client sites that we can. So if you were considering, not you, Julia, but the audience were considering a showcase, then we can, even if we weren't involved, we can provide very useful information about how to go about it, and how to maximize the benefits. And I think it's important to say that it's not as I mentioned earlier, it's not a one-off project. It's a story that will keep giving us more stories as time goes by. We will learn more, we will do more, and we will be able to present continuously new results from this project.
Okay, thank you very much, John. So our last question is from Gohar Mir. Do we know how much EPC score improvement is possible if we were to switch completely from LPG to 100% bioLPG, assuming bioLPG ISCC EU gets accepted in the EPC framework? I believe to John also this question.
I'm sorry about that. Yeah, it's come back to me again. Apologies. You have to hear droning voice. But it's difficult to say, is it Goa that asked the question?
Yeah.
Because it is not the, and this is the paradox really. The energy performance certificate originally was concerned with energy efficiency. So the fuel, what has that got to do with energy efficiency? It's how you utilize that fuel, whether your technology is and your management is going to use it efficiently. However, what's crept in over time is this desire to use, as we all understand, lower carbon fuels. Okay, so I think we will get a certain improvement through utilizing renewable energy, but we also have to make sure that we use energy as efficiently as possible, because the zero emission building, which is the ultimate target, and which the expectation is by 2050 all buildings will be zero emission buildings. The definition is that the building should use as little energy as possible, but that energy that primary energy that is used by the building should be covered by the generation of renewable energy or the provision of renewable energy. So you can either generate it on site or you can deliver it to site. The EPBD allows this sort of renewable energy to cover. But what you do first of all is reduce the energy consumption as much as you can through insulation, through air tightness, through using efficient technologies. So it's a combination of the two. How much you get for energy efficiency, how much you get for renewable energy use, I'm not absolutely sure, but I think you will get some for renewable energy use and more probably for energy efficient use of energy efficiently. We don't want to waste, we certainly don't want to waste any precious renewable liquid gas. And we don't want our customers to waste it, of course. Hope that's answered your question, Goa and Julia.
Okay, thank you very much, John. So I'm seeing that we are running out of time, so I would like to finalize this webinar. I would like to thank all of the speakers, so John, Eva, Wendy, Matti, and all of the participants to being with us here today. I would just like to invite you all for our next showcase event that we are going to have in the beginning of next year, an in-person event. So stay tuned for our next events. Thank you very much for your participation.